This video lesson will take you through the highlights of dissolving and solubility. The objectives covered by this lesson will include 15E, 15F, 15L, 15M, and 15N. The notes that you need for this lesson can be found in your notes packet beginning on page 2. One of the most important things to understand about the dissolving of compounds is what happens on a molecular level when the water dissolves the compound. We're going to start here with a little animation of a process called solvation. Solvation is simply water molecules surrounding the dissolved particles. In particular, we're going to start by looking at an ionic compound. Here we have a crystal of some kind of ionic compound, maybe sodium chloride. In this little animation, the negative ions are blue and the positive ions are gray. I'm going to run this again, and I want you to notice that water, being a polar molecule, has a positively charged end pointed in the direction of the white hydrogen atoms. So these are the white hydrogen atoms on water. And water has a negatively charged end associated with this red oxygen atom. Notice that the gray particles, which are positive ions, end up surrounded by the partially negatively charged oxygen atom, and the blue particles, which are representing the negatively charged particles, get picked up by the water molecules with the partially positive hydrogen end pointed in. Here come some water molecules to take away a negatively charged particle, and then here are some taking away a positively charged particle. If we look up close at this negatively charged particle being solvated, you'll notice that the partially positive hydrogens on the water molecule surround the negative ion and pull it out of the crystal. Notice that dissolving takes place on the surface of the substance. If we look at a close-up view of a positive ion, here comes the partially negative charged end of the water molecules, and the partially negative oxygens surround the positive ion and pull it away from the crystal. And if we put the entire solution in motion, what you'll notice is that each individual ion is packaged up with a whole fleet of water molecules completely surrounding it. Every ion has its own set of water molecules and is free to move about independently. For this reason, solutions that have ions dissolved in them can conduct electricity because the positive ions and the negative ions are free to move independently of one another and carry the current through the solution. In more of a still frame picture, we have a little diagram here of the different steps of the solvation process. We have the partially negative end of the water molecule approaching the positive ion, the partially positive end of the water molecule approaching the negative ion. The cations get pulled away and surrounded by water molecules with the oxygen end pointing in. The negative ions get surrounded by water molecules with the partially positive hydrogen atoms pointing in. And here we have a positive ion and a negative ion that have been fully solvated by water molecules. You will be asked on your test to draw a picture of ions that have been solvated by water, so make sure that you understand this process.